When a health inspector steps into a pre-fogging environment, the margin for error effectively disappears. They are immediately forced to process multiple streams of data at once, calculating potential chemical exposure limits, verifying their protective equipment is properly sealed, and scanning for unpredictable physical hazards hidden in the space. A single miscalculation or skipped step in protocol directly translates into physical harm for the inspector or the surrounding public. Because these stakes are entirely physical and immediate, standard classroom preparation falls short. Reading about hazard awareness does not build the muscle memory required to actually navigate one. Historically, we have relied on learning management systems to deliver this training. These platforms are typically deployed as passive repositories, asking trainees to click through compliance PDFs and complete basic multiple-choice quizzes. There is a massive operational gap between passively recalling a safety manual at a desk and actively deploying knowledge under stress in a contaminated zone. Online training offers incredible scale and flexibility, but those benefits are useless if the platform cannot simulate real behavioral judgment. This is where gamification enters the architecture. Properly applied, this does not mean trivializing the material with arcade mechanics. Instead, we can construct a risk-free, 7-stage simulation environment by integrating specific, outcome-focused interaction mechanics directly into a standard learning management system. Active scenario navigation turns the LMS into a simulator that builds actual behavioral competence. Recent data from researchers like Lee, Kanade, and Latore establishes a clear baseline. Game-based training actively improves hazard recognition and overall occupational safety knowledge. The primary misconception is that gamification requires the inclusion of arbitrary points, countdown timers, and competitive peer leaderboards. This comparative model illustrates the danger. Introducing competitive mechanics into high-stakes safety training encourages prioritizing speed over accuracy, creating a paradigm of rushed decision-making. The alternative is a system engineered around goal clarity, immediate feedback, and strict competency gating. In a mastery-based model, the learner does not advance by beating the clock. They move forward only when they have proven absolute behavioral competence in the current task. An ethical approach to occupational health and safety explicitly rejects competition. The objective is to slow the learner down so they fully internalize strict procedural protocols. We construct a 7-stage digital training pipeline. After orientation, Stage 2 introduces hazard awareness via a hotspot mechanic. This interaction forces the learner to actively scan the environment and flag anomalies, mimicking visual sweeps executed on site. Moving from visual scanning to procedural application, Stage 3 covers personal protective equipment readiness. A drag-and-drop selection mechanic requires the learner to physically match specific pieces of safety gear to their corresponding hazard profiles. Mapping physical actions directly to targeted digital interactions reinforces procedural memory long before the learner ever touches real equipment. The curriculum shifts to the unpredictable human elements, site safety and resident communication. In branching scenarios, learners select dialogue paths to manage confused simulated residents. An improper response instantly halts progress, delivering targeted, corrective feedback explaining the failure before resetting the scenario. This rapid feedback loop functions as a continuous formative assessment. It provides the learner with the critical opportunity to fail safely and recalibrate their communication approach. Simulating human interactions digitally ensures that communication breakdowns are resolved inside the platform, preventing dangerous escalations during live operations. The pipeline culminates with Stage 6, equipment and chemical safety, and Stage 7, the final competency challenge. These stages rely on intensive action sorting and a rigorous readiness checklist. As the learner interacts, the system is listening. The engine powering this entire framework is a standard learning management system, like Moodle. Every interaction within the hotspots, every dragged item, and every branched dialogue choice generates a deep layer of telemetry data. This data feeds directly into progress monitoring dashboards, generating highly specific diagnostic reports for training managers. At the end of the pipeline, the system issues a digital badge. This badge serves as the file, immutable proof of mastery required to unlock live field deployment. By tracking these specific behavioral inputs, the learning management system transitions from a passive content server into an active diagnostic tool that proactively identifies critical learning gaps. Implementing this framework also requires designing for the practical constraints of modern workforces, ensuring the interface is mobile-friendly, accessible on low bandwidths, and built with inclusive design principles. This structured architecture takes highly variable physical field conditions and maps them directly to outcome-focused digital interactions. The digital badge serves as a verified record of the behavioral competence proven during the simulation. With their procedural memory and hazard recognition fully tested, the inspector can execute their physical duties with precision. What begins as a stream of data flowing through a learning management system manifests as life-saving operational readiness on the ground. Gamification has the capacity to rescue occupational safety training from the trap of passive compliance. But that integration must remain strictly focused on developing safety competence through an ethical, stress-free implementation. Training managers must discard superficial competitive tricks in favor of building robust diagnostic mastery pipelines. True gamification in high-stakes environments doesn't gamify the consequences of failure. It meticulously engineers the path to